EDM, or electrical discharge machining, is a non-traditional machining process that uses electrical discharges, sparks, to remove material from a workpiece. It's commonly used for precision machining of complex shapes that are difficult to achieve with traditional machining methods. Here's a brief explanation of the EDM manufacturing process. Overview. EDM involves the removal of material through controlled electrical discharges between the workpiece and an electrode. The workpiece is typically made of electrically conductive materials, such as metals, and it is immersed in a dielectric fluid. Setup. A workpiece, often referred to as the part or job, and a tool electrode are placed in close proximity, with a small gap maintained between them. The workpiece and the tool are connected to a power supply. The workpiece is usually connected to the positive terminal, while the tool is connected to the negative terminal. Dielectric fluid. A dielectric fluid, such as oil or deionized water, is used to fill the gap between the workpiece and the tool. This fluid serves multiple purposes, including cooling, flushing away debris, and acting as an electrical insulator. Electrical discharge. When a potential difference is applied between the tool and the workpiece, high-frequency electrical pulses generate sparks or discharges between them. These electrical discharges create intense heat, melting and vaporizing small amounts of material from both the workpiece and the tool electrode. Material removal. As the material is removed in the form of tiny particles, the dielectric fluid flushes them away. This continuous process results in the desired shape being machined on the workpiece. The removal of material is precise and can achieve very fine details, making EDM suitable for intricate and complex geometries.